Welcome to our next episode. In this episode, we're going to talk a little bit about how it is that we can maintain an inventory of the different hosts that are on our network, and even detect changes to that inventory over time. Now, we're not going to talk about all of the possible ways that this can be handled here, but we will start talking about the problem and introduce some effective ways for managing that problem. So right now, I've logged into one of the Unix machines on our network here, and I have a piece of software installed called PBNJ. Now, PBNJ is available from SourceForge. We'll put the link up in the show notes. And it stands for not peanut butter and jelly, but ports, banners, and junk. And while the project hasn't had a lot of activity in recent time, it turns out that it's still very, very useful for automating scans and keeping track of results that are happening on the network. In order to use the tool, there are two main pieces to the interface. The first is scan PBNJ, and the second piece is output PBNJ. Now, we could look at the help that's available here, just the quick reference, but there are also full manual pages available for each one of these tools. So we've already taken a look at some of the options that are available here. I use the tool from time to time. So let me just introduce you a little bit to how we can use this tool. First of all, in using scan PBNJ, which is optional, you could choose to run your scans directly using something like NMap, which is actually the tool that's going to be used under the hood here. But scan PBNJ can also initiate and run the entire scan for you. When you use this tool, it is possible to simply run it and specify which systems you'd like to scan. For instance, I'm currently connected to a subnet here on 10.0.1.0/24. So I could simply enter that in, and it will now scan that entire subnet for me. But one of the problems that we have in maintaining the inventory of a network, both as an auditor and a security professional, is that from time to time we'll run across systems that are just too sensitive to scan. That could be because the machine is maybe unstable. It may be that there are some unusual behaviors when you scan the system. It could also be that while there's no problems that you're aware of today, the system itself is just so sensitive that if that system were to go down because of a scan, it would be unacceptable. So you may choose to exclude that host. This is where we start getting into the problem of both scoping and also how do I actually manage these scans, because I'd really like these scans to be running regularly. In fact, as we work with customers with this, we tend to set up a system that will have the scan run nightly so that we can have an up-to-date picture of that network at any given time. Should there be a new vulnerability announced or anything else, rather than having to now scan the network to find it, we can simply look at last night's report. Of course, that's also useful for finding out what's changed in, let's say, the last 48 hours, or maybe in the last week or the last month. So we can track systems that are coming up and coming down, versions of software that are changing, ports that are opening and closing, giving us really good change management. Now, some of that is a little bit outside of the scope of today's presentation. You can find more information on it. In fact, I teach a whole class that will go through that particular topic. But here we just want to talk about how to use this particular tool to manage this problem. So let's say we've decided that we are interested in the entire population of the network, but there are some hosts that we just cannot scan for our scope. Well, to handle that, rather than trying to specify the hosts here at the command line, which, by the way, you can specify as many as you'd like to, you simply comma separate all of the different hosts. There's only one adjustment to the normal way of scanning things for NMap. If you wanted to use an asterisk here, you're not going to be able to put the asterisk directly on the command line like that. If you do, the shell will interpret it, and you're going to end up with trying to get a list of file names that begin with 10.02, and scan PBNJ will not see the asterisk. Instead, you have to simply escape the asterisk with a backslash. Now that will be passed in correctly into the targeting engine. But like I said, we want a more effective way to manage this than the command line. So let's see how we could do that. I would start by doing this. We'll start up a scan IP list, which could be any file you want to, anything you want to name it. I'm simply going to call it that. And inside of this file, we can start creating a target list. Now, I'd I'm going to keep it simple for this particular episode, but just for scalability, I have exactly this kind of system using a slightly different tool, running on large networks, even Class B networks with multiple subnets. And we do exactly this process. We simply define a range of hosts for each subnet that can be scanned, so we will now exclude the ones that could not be scanned. And we even have one on this particular subnet that I'm connected to that we should not scan. The machine that I don't want to scan is 10.0.1.64. Now why not? It turns out that that system is a printer, and that particular printer, there are no updates available for it, no changes in firmware, but it has a big problem. If I port scan that machine, it's going to spit out about 25 to 30 pages of blank paper or with garbage printed on it, even though I'm just port scanning it. That would be an example of a kind of system that maybe you're not going to want to scan every night. That's going to become irritating to people. Now, in the long run, it would be good to keep track of what's happening with that system, so I do want to periodically check and see if there's updates available, or maybe if there's some manufacturer information that would allow me to change that behavior. But for now, I simply want to skip that system. Well, that's easy enough. Why don't I simply scan 10.0.1, 1 through 63, and then I also want to scan 10.0.1, 65 through 254. And I'll simply delete this line. So I've created a really simple list of hosts, but instead of putting a separate host on every line, I'm simply listing each of the sets of networks that I'd like to scan. And that works perfectly well. In fact, what we'll typically do is put something more like this. So we would have each subnet listed, maybe I can even list more than one, 2 through 50, and then the hosts on that subnet that can be scanned. And if possible, working with the operations team, maybe we can see if we can get those sensitive systems that shouldn't be scanned and move them to a single block of IP addresses. For example, if we were to move all of the printers in our environment down to a certain range, and maybe put the sensitive printers that are not able to be scanned down into the lowest part, I might be able to do something like this. So hosts or networks 2 through 50, hosts 6 through 254 need to be scanned. We're skipping over 1 through 5 because I know that if there are sensitive systems that can't be scanned, they're going to be there on the network. So working with the operations team, you can make this a manageable process as well. For now, we're just going to keep this simple list. So we're going to run scan PBNJ with the -i option, which tells it to use that input file, the scan IP list file that we put together. And I'm also going to add a few more options. I'll use the --rpc option, which will tell it to scan for RPC services and keep those banners as well, so we know what sorts of systems or services are running. I'll ask it to use the -r option, which allows me to specify the port range that will be used in doing the scan. By default, PBNJ will only scan the first 1025 ports. But if we're trying to maintain an inventory and then use that for auditing to detect change over time, we're going to need to scan the full range. So I'll add in 65, 1 through 65.535. And we'll also add the -p option. The -p option will tell it to also detect changes that are happening in banners for ports that are listening. Now, what's actually happening to these results? Where are they going? Oh, I'm sorry. The -p is not the banners. The -p asks it to ping the host first before it runs the scan. Now, that's an interesting problem. Pinging the host first. Why would we want to do that? Well, NMap, when it performs a scan, if we use scan PBNJ with the default options, is going to use a -P0 scanning option, which means do not ping the host first. Simply scan. The reason this is an issue is that that is going to make your scan extremely slow, especially when you're scanning large networks. Because if there's a host that's not up, it will take a very long time for that scan to complete. Instead, by specifying the -p, it will now ping the host first, see if it's there, and if it's not currently up, it will not scan the host. Now, won't that create gaps in our scan? Well, sure it will, but over time, we're going to have a complete picture here, and one of the things this will detect for us are changes that are happening daily, weekly, or however often we'd like to do the checking. So those gaps are detectable if a host has disappeared or if a new host has appeared. But for now, this is going to be a much more effective way to handle this. If you're running in a Windows environment, which most of us are, we do have another problem though. In the Windows world, we have a default firewall setup that is not going to respond to a ping. So again, to manage the scope on this and make it effective, what we'll usually do is set up an environment and authorize scanning host. And that host will be used for doing all NMap vulnerability or any other kind of scans that might need to happen. And that's where something like scan PBNJ might exist. Now when that scan is set up to run, each night it will run, but the Windows firewall through group policy is configured to allow that particular host to run pings. This now allows us to have a really complete picture of our network without having to open and close holes in firewalls and drop firewalls temporarily for scans to happen. Now there's only one host that those hosts will permit them to scan on, and now we'll have that complete picture. We're going to jump ahead to where the scan has actually been completed so we can see what the results look like. So the scan is now completed, and as you can see, I've got some results that I can scroll down on my screen with here, showing all of the different systems that were discovered. Now looking at this, aside from just being cleaner output than what you would typically see using just NMap, you may wonder, what's the real value here? Well, the value comes in the form of the output PBNJ tool. The output PBNJ tool allows you to do all kinds of queries against the information you just created. But where is the data? It's actually automatically put into a database. Now, you can use this particular tool with MySQL, Postgres, or, as the default is, a SQLite database. So it will create that on its own. If you'd like to change it so that it will use, let's say, Postgres or MySQL, there is a config file that you simply change to give it credentials and describe where the database will be. Additionally, inside of the README file that comes with the tool, you can get information on what the actual database schema is. But what kind of queries can you actually do? Well, let's just do the output PBNJ with a -list option, and it shows all of the different options that are available. Now, the ones that are listed here are a little bit basic. For instance, if I wanted to find the SSH machines, one of the things that's listed, we could just pull this up, tell it I want to do a -q query for SSH machines, and it will now pull that out of my database, showing me the different versions that we have running, the different operating systems that are installed on those machines. But what if I want to change that? For instance, this is going to do SSH machines. Maybe I want to find web servers or SSL servers, or, well, you can change these queries as well. They're simply stored in a configuration file called query.yaml, and we can modify the SQL statements right in there. Or, if you're not very familiar with SQL, you could of course talk to a SQL administrator, a SQL database administrator, who might be in your organization already, who could make modifications to the file based on the query, or I'm sorry, the schema that we can provide him. Well, that's all we're going to cover for this episode, but we're going to look forward in the next episode to how we can even scale this better, being able to do change detection aside from the monthly and daily reports that are made through this tool here, showing changes in ports as they happen.